Welcome, listeners, to the Asset Reliability at Work podcast. As you may know, we cover a bunch of topics centered on asset management and reliability for manufacturing facilities. We share insights directly from the professionals who are in the field, talking with plant leaders, developing asset management plans, and coordinating those next steps for reliability success. In this episode, we'll speak with Paul Langan, who is a senior reliability technician at Lifecycle Engineering. Paul is joining the podcast to help us answer some of the major questions centered on asset hierarchy. We'll go into the weeds of asset hierarchy by discussing topics such as the type of assets that should be cataloged, the importance of developing a parent-child relationship within your hierarchy system, and how to optimize your hierarchy. Now, let's get the conversation started with Paul Langan in validating and optimizing your asset hierarchy system. Now, as I do in the beginning of every new episode, we have Paul Langan here, and just to kind of kick things off, Paul, if you don't mind, just give the audience and myself a little bit of your background.
My background is prior Navy. I joined the Navy in 1964, retired in 1988, submarine service, Special Forces service, Navy SEAL background as well. I joined Lifecycle Engineering in 1988, and my initial jobs was with one of the co-founders of the company, overhauling motor generator sets on submarines and aircraft carriers for a couple of years. And from there, we did a lot of preventive and predictive maintenance work for different companies throughout the United States and the world, actually. I also taught classes for Clemson University and the University of South Carolina in mechanical power transmission courses, which is coupling alignments, motor alignments, bearing installations, gearbox overhauls, pump overhauls, anything to do with the mechanical side. I taught those classes for Clemson and University of South Carolina for several years. The reliability consulting group, we are strong in both the hierarchies and PM, PDM development, failure modes and effect, condition analysis, root cause analysis, and I help do all of that as well. So I've been with the Lifecycle Engineering for over 28 years, worked in every industry there is, from oil industry, mining, gold mines, silver mines, the grain industry, and so on. So we do a lot of in-field studies and analysis to determine what is causing a lot of the equipment to fail, and we recommend and actually perform those improvement activities as we need to. So.
All right, now let's move into the nitty-gritty of asset hierarchy. So the first question I'm going to ask you, Paul, is to explain what asset hierarchy is and why it's important in today's plant environment.
The asset hierarchy structure that we currently require and need in the field is paramount to most organizations and companies. And the reason I say that is that without a structured system arrangement and alignment for their systems, there's no way that we can have the accountability, traceability, and maintainability of our system assets and components in the field. Without that structure, we can't drive maintenance to where we need to. We cannot understand what our general ledgers or GLs are and how our costs are really running up or down. And we're really losing a lot of money without a structured system in place. So with that said, that we should really look at the overall structure of how we're looking at our components and subsystems in an industrial and systematic environment, to make sure that we're charging where we should be charging, manpower is allocated to where it should be, and parts usages are in the correct manner.
That's a great explanation, Paul. But now let me ask you, what types of items should be cataloged?
When we're talking about cataloging an asset, there's several things that we need to consider. One, we need to consider if that asset is a maintainable asset. A maintainable asset would be one that we would want to drive maintenance to. That's not necessarily always the case, where we would look at some components could be a single point failure in the field, and that could hold equal merit or importance to the overall system performance, that if it failed, it would also need to be considered in the hierarchical structure. So when we say maintainable assets, that's one thing that we would always establish prior to actually optimizing, reorganizing a hierarchy, with the client in the space. But we do consider the single point failures. Is there a workaround, or is there redundant systems? So when we're looking at those maintainable assets, what we don't want to do is drive our maintenance program down to those bill of materials items that are essentially throwaways or do not require any maintenance on them whatsoever. Examples of that would be like a limit switch or a pressure switch, important to a system. However, we don't want to have one specific planned maintenance activity to go out and look at a limit switch. We'd want to look at what that limit switch is functioning to and controlling with. For instance, it may be a tank level switch. We would want to look at that in a maintenance perspective, but yet we wouldn't want to have that as an individual component in a line item. So we need to consider multiple factors when we look at that maintainable asset point of view, but they all must be considered. We have to look at the importance. We have to look at safety environmental. We have to look at safety personnel when we're looking at those maintainable assets.
So, Paul, you wrote an article on this very subject, and as I was reading it, I came to the part where it talked about validating your assets. What's the need to validate those assets?
The asset hierarchy validation is probably one of the most important functions that should be performed and is required to be performed by multiple people. So when we go out and do a validation of a hierarchy, we're looking at a structure that already exists in a CMS system for the client. What we want to look at is see how they're structured. Are they in compliance with ISO standards? And in particular, we always use the ISO standard 14244, which is a taxonomy of the system where we go from basically a 1 through 9 tier hierarchy. We use that as a baseline so we can establish a logical parent-child relationship and roll those costs up to the system or level where we would like to control those. So when we're talking about validation, why do we consider that? Why is that important? And simply put this way, in most cases, and in most all cases, the hierarchy that exists is not accurate. If we don't have an accurate system hierarchy illustrating all those assets that are in the field, then there's not any possible way that we can run cost to the right level, be it your level 7 or your level 8 systems at all. So to expand on that just a little bit more, what we have to do is take the existing hierarchy to the field with the existing process and instrumentation drawings and go line for line, item by item, valve by valve, and make sure that everything that's in the field reflects on the existing hierarchy. What do we normally find is that we're going to see many assets that were deleted or removed from the system that are no longer there, but yet still reflect in an active hierarchy in their CMS system. Conversely, the other side, we will see assets that were installed, but yet the system has not been updated, more than likely due to a management of change process that does not work or has not been activated properly. So we've got new assets in the field that are not currently residing in the CMS system. So there's the two sides of the validation. One, we have assets that reflect in the current system load in the CMS system that are not there. The other side, we've got assets that are new in the systems that still have not resided in there, have not loaded them in. So how does that really affect the overall productivity of a system? Take as an example, if you've got assets that have been removed from the site, a planner typically does not know this. He's still carrying a parts load for those assets that have been removed. He's probably got preventive maintenance and predictive maintenance still assigned to him. Now, that does not necessarily mean that the technicians are performing maintenance on a removed asset, but what it does mean is that there is time allocated to go out and see if they're still there or not, there is parts being used or not. So if we're looking at things that have been removed from the system, there is a lot of time and money spent on those assets that do not exist. Conversely, let's look at those new items, new assets that were installed that the planner does not know anything about. With that said, he no longer then can drive maintenance to those assets. The preventive predictive maintenance methodology has not been applied to a new asset, so if it's not being maintained, it has a high probability of failure. Also, if a new asset has not been properly loaded into the system, we're also not going to have the parts required that if it should fail, or the normal filters, oils, and greases that it would take for its normal health stocked as would be required. So that's the validation process. We really want to make sure that your CMMS system has what actually reflects in the field. From a regulatory perspective, that if you are at a client site, which you fall underneath one of the OSHA regulations, and if you had an accident that happened, a small emission or whatever that could be, a spill, and OSHA came on site, the number one and the very first thing that they look for is your set of P&IDs and your asset hierarchy that resides in your CMMS system. If they find and determine that there is a new asset that has been the cause of the spill or the release, and you're not performing the required preventive maintenance on that asset, then in fact you could be open for a lot of heavy fines and liabilities. So it's important that the CMMS system reflect your current asset loading and also your maintainability of those assets has to be determined. Also, your management of change system must be active and it must be viable, and that is the responsibility of the reliability engineers to make sure that that in fact happens.
So now let's move on and talk about the considerations that have to be made when performing hierarchy validation. Can you speak to what those considerations are?
The considerations that have to be made is, one, for me, that you have to have a lot of involvement from the people that are doing the validation, or the actual system owners, subject matter experts, so to speak, that when we do those validations and when we make sure that the hierarchy is right, we need to use variances of documents and publications, the P&ID I mentioned prior, your process flow diagrams, possibly even your OEM tech manuals and so on, to show what kind of maintenance should be having. Even though the hierarchy does not reflect maintenance activities, it does support where our maintenance activities should be. Again, back to what the maintainable asset is, and that is normally determined by your process flows, your process hazard analysis, your PHAs, and also your P&IDs. So if we're looking at why we want to have a hierarchy validated, why we want to have certain credentials, certain pieces of paper, for instance, a validated P&ID, which truly reflects the components and assets in the field, that should be looked and validated. Usually, typically, we like to say every 18 months, maximum 24 months, to make sure your system configuration is accurate and true. So there's team members that's involved with doing this, typically your REs, your system owners, your electricians, mechanics, your instrument technicians, just to name a few. You also have to remember that there's more than just rotating and stationary assets. You know, our tanks and pressure vessels being stationary, pumps, motors being rotated. Typically, the forgotten asset type is linear. Linear assets, which is the piping systems, are not considered in most cases. They still are required to be tagged, required to be numbered, required to be labeled, and maintenance is required to be driven to those linear assets in the same manner that we do stationary and rotating. In a lot of cases, if we have toxic chemicals that we're working with, if we have propylene oxides, if we have any type of other caustic chemicals, if we've got gases, ammonias, and so on, that piping system must fall under a risk-based inspection program, And the only way we know how to manage that is if we have a very accurate process and instrumentation drawing, P&ID. So when we talk about that process and the consideration of what we need, then we really need to know all the players that's involved with that. So we would have a stationary engineer, rotating engineer, and a linear asset engineer that would assist and concur with the findings of the field. So it's extremely important that we know what we're doing, what we're seeing, and what's there. Discussions are, well, how far down do you go, in an asset hierarchy? And again, we'll go back to maintainable asset, exception to the rule. If you do a process hazard analysis on a chemical or on a system that falls under the OSHA of 1910-119, then we can in fact say that we're going to have to put maintenance down to that 1/4-inch valve. Whereas if it is a non-compliant system, we may have to only go down to, let's say, a 6-inch valve, where we need to do some type of inspection and maintaining that system. It's important that the key players establish these rules at the very beginning and understand if you're part of the mining community, MSHA rules, OSHA rules, and all the other rules that's considered both state and federal government before you establish what your maintainability or your assets are. What is your lowest maintainable asset? A lot of times it's governed by federal and state laws.
So, Paul, as I kept reading your article, I came to this concept of parent-child relationship. So why is it so vital to establish a parent-child relationship with your assets to help create that functional hierarchy system?
The parent-child relationship is a structure of assets in such a manner where we can roll cost up to a higher level to that asset, and we can drive cost and maintenance to the proper level. So as an example, we may say that we've got a tank in the system. That tank could be the parent. The relief valves, the pumps associated with that tank, the piping coming into or out of the tank could be children of that tank. What is important with that, it is how we drive our maintenance activities to that lowest maintainable asset. By being able to establish a parent-child relationship in accordance with the ISO standard, that you'll be able to drive your cost down to that lowest maintainable asset and then roll those costs up. Instead of rolling cost up, let's say, to a level 5 or system level, let's take a water system, and everything rolls up to the water system. When we're trying to determine what our bad actors are or where most of our money is being concentrated at, if we build a true parent-child relationship, then we can drive that down lower. So in a water system, we'll probably have a water storage tank. Well, there would be your next level below the system. Now, under that tank, we should have transfer pumps. We'll have valving. We'll have piping. We'll have instrumentation and control systems, level control valves, pressure control valves, and so on. So as we drive it down to that lower level, so now we've gone from a system, gone down to the actual tank itself. That's below the system. One level below that now is the pumping, the valving, and so on. So now we can say that if we have that parent-child, we can say the pump is a child of the tank, the pump-motor combination is a child of the tank is a child of the system. So now when I drive my work orders down to the pump, I can see that the costs are at that pump. I can easily identify then where my problems are. And as those problems begin to collect, we can then take a look and do some analytical studies of where is my money being spent? How do we want to do our maintenance activities? We can then reevaluate our maintenance activities and say, I'm having a mechanical seal failure on this pump. I'm inspecting it every 6 months. But at the 6-month level, I'm finding it's too late. Maybe I need to increase my frequency to every quarter. So let's do that. Well, we still have a problem, but now we can identify we've got a pump seal problem. Maybe it's a parts problem, and then we can start doing some studies. If we're at the system level, we have no idea where our problems are. By having your parent-child relationship and cost rolling up from the lower to the higher, then we can see where our problems are quickly identified, see if our maintenance activities are correct or not, Can we extend our periodicities further out, which we would like to do? Should we replace our current inspection program with predictive maintenance, PDM, which we should do? So we can see all of that if we drive our maintenance activities, and that's all based, again, off of a structured hierarchical system of having it at the proper level to be able to determine where your costs are, where your risks are, what we need to do to mitigate those failures as they come through us, and we can see that then if we get it at that proper level.
Now, Paul, I'd like to ask you one final question before we wrap up today's episode, and it's an important question as it has to do with optimizing your hierarchy system. So, first off, what do you mean by optimize, and then how is that activity or function played out?
Well, you can optimize the hierarchy by doing several things. We kind of discussed those a little bit in the beginning. Optimization is making your hierarchy true and accurate to what is existing in the system. Remove those things that do not need to be in there. For instance, deleted equipment that is no longer used, equipment that's been removed should no longer show in your hierarchy structure. So we need to do that. That's part of the optimization, consolidating your hierarchy by looking at what's there and what should be there. The other side of that is what should be there that is not there, so it's accurate. So the optimization, we're looking at several facets of that to make it accurate. The P&ID also will be marked up when we do a validation in the field. Those drawings are hand marked up, turned over to a draftsman so they reflect the current state. The old cliche of, as well, it's always that way, that's fine, we need to do that. That does not work in today's world. We're trying to streamline. We're trying to make sure everything is pointed to a system that's good or not good. The other thing that we always want to look at is that what can we do with an accurate system to, if we had to shut part of that system down, can we have a workaround, a bypass around? Is the system redundant? If I have a tank, as an example we talked about before, water tank, I've got a pump failure on that tank. The planner needs to know if he's got a second pump that he can start up. That hierarchy structure will show him that. He just looks it up and he sees, yes, I have it. If we have a single point failure, then we in fact have lost that system and shut down. Therefore, performance is down. And if performance is down, naturally our end product is out the door. And every company is in business to make money and put a product out the door no matter what that product is. The hierarchy structure will show that. It helps plan, organize, and stabilize our systems that we have out there. A lot of managers, plant managers in particular, sometimes do not understand the importance of a validation. For the few $1,000s that it takes to do a hierarchy validation, the benefits of that is probably tenfold in a short period of time. Just knowing what you have, what you don't have, and where you're rolling your costs to, so you can get your true systems that we need to have actually looked out there. So the optimization is just basically cleaning that hierarchy up, making sure what you have is reflected truly, making sure that what's out there is there, and what you think is gone, in fact, is gone. And you can start doing the deletion in your system when you get back. And understanding that if you've got deleted equipment, there is a way to decommission that equipment as well as commission new equipment. And your hierarchy should reflect all of that.
Before we do our final send-off, I'd like to first and foremost thank Paul for stopping by and being a participant on the LCE podcast channel. Paul, you provided some great, valuable content to our listeners, and we definitely look forward to having you on the show again sooner than later. Also, I want to direct our listeners back to our show notes where you can find 2 links to additional resources. The first resource we made available is to Paul's article on this very topic. Paul's article provides some extra comments and details that we just weren't able to cover in this episode. And now the second link directs you to a functional hierarchy chart that will guide you through the development of a sound hierarchy system. Again, you can find these links directly in our show notes. Once again, thank you for joining us, and be sure to visit the LCE website at lce.com to listen to more episodes of the Asset Reliability at Work podcast. Hey, listeners, one more thing before you go. If you have any feedback for the show, or you have maybe some suggestions for upcoming topics you'd love to hear about, we'd like to hear from you. So there's 2 ways to get in contact with us. The first is on Twitter. Our Twitter handle is @LCE_today, so be sure to follow us. And then the other way is to email the show at podcast@lce.com. Once again, thank you for joining the show, and we look forward to more episodes on the Asset Reliability at Work podcast.